This video is about the Sofia tube tester, made in Italy in the year 1995 by the Audiomatica company. Now, Audiomatica is a little bit strange company. You need to like them, and if you don't like them, you probably won't like them at all. But if you like their products, they're actually quite good. Sometimes a bit difficult to use, sometimes a bit unusual, and the Sofia tube tester was made by them, if you ask me, as a sort of a digital replica of the Tektronix 576 tube tester. But I will be saying something more about this when we have the program running. Now, this tester is made in 1995, and there was no Windows at that moment. There was only MS-DOS, and the operating system you need for this is MS-DOS. And when you start up the program, it looks a little bit like Windows, like old Windows 3.1. So it is an MS-DOS program, but actually, for me, it looks almost like Windows. It's a little bit a primitive kind of Windows, but it's fair enough, and it's kind of Windows oriented. Now let's start the program. For this, I have to type in the word Sofia. That is the way it's done in MS-DOS. And then the program starts. As you see, it needs no time to boot, 1 second, and it's already there. A lot better than Excel programs or other modern programs. Now, first thing I have to do before I can start the test is select a directory where I have put my tubes that I want to test, because this I have already prepared. So I change now the directory to VT4C. That is here. Directory is now changed. Now I can measure plate current, and I select the tube from the directory. In this directory LZ, I have only 3 tubes, as you can see here. I take the VT4C, I load it, done. So now I'm prepared and ready to do the test. The data of the VT4C is inside the program now. First thing, of course, when you start a test, you have to switch on the heater. Now you can see the VT4C lights up very nice, very bright. It's a big tube. This is 40 watt heater power. But I switch it off now, and I want to show you something else. When you switch on the filament, of course the program has to wait until the filament is warm. Now the AT1000 tube tester, of which we have 3 here, doesn't have a very sophisticated method for that. It just waits a certain amount of time, which is they think is probably a good time. And all of that time you have to wait for the filament to warm up, and it sort of delays your work. Now, if you do this with the Sofia, it works a bit different, because the Sofia tester monitors the plate current. The filament current. And if the filament is warming up, the resistance of the filament is going up. And in the beginning, the filament current will be very high, and then it will stabilize at the final value. And that is the moment where the filament is warmed up. Now, and then already you can start the test. If I switch on the filament, you will see a waiting sign coming up. This waiting sign means the filament is not warm. Now it is warm. So the resistance is not changing anymore. If I switch it off again and then switch it on, you'll see it needs a shorter time to wait. Now I have the filament glowing, and I can start my test. I press start, and there we go. When I do so, the hazard lamp is burning blue. Originally there was a red LED in there, but I put a blue LED in there because I think blue looks more dangerous and reminds me a little bit more of hazard. Now you see these yellow LEDs, they are blinking, and these represent the status of the serial port. So you can see serial information is being transmitted, and all of this is every time a series of curves. So finished, next curve, finished, next curve. And I've programmed this for 11 curves, so the program should be almost finished now. 1 or 2 curves, and there it is. Now here we see the curves of the VT4C. if you look at the screen, right now this is only static. And if you would have a Tektronix a curve tracer of the same design, you can only look at the numbers and that's it. But here I have my mouse. Now what can I do with the mouse? Look, I put it wherever I like, and I can put it, for instance, at this measurement point here, which is 560 volt, 60 milliampere, and then I can see on the right side what is the change of the data, because the dynamic data of the tube is not a constant number. So if I look at the transconductance at the GM, you will see it's a function of the position, because the GM actually is the slope of this line, and the slope here is not the same as here. Here it's much less steep, and it goes up all that way. So if I would go along one of the lines, like this line for instance, I would go here, I would see that GM is getting smaller because the slope of the line is changing here. I will show that to you here. So I take this line, and here you see that GM is 3.87, and now I'm moving down the mouse along this line, and you can see the GM for here, for instance, is only 1.77 is left of it. So the GM is a function of the position in the curves. The same applies for the plate resistance, because it's also depending on the angle of the curves and on the distance of the curves, and the same applies for the mu, which is the gain of this tube. Now here comes already one of the most difficult things with interpreting curve charts. People think they can look at the curve chart and understand from this if the tube is good or bad, but I've been doing a lot of this myself, and I have to admit this is very difficult and sometimes not even possible at all. One of the things you can do is just extract a single number from it. So I take, for instance, this number here, 630 volts, 90 milliampere. Then I see that the grid voltage needed for this is minus 13 volts. And you can look in the data sheet if the grid voltage is the same of the tube that we are testing as in the data sheet. Now if the tube is getting older, it doesn't like to pull as much current anymore, and you would have to use a lower grid voltage as with a new tube. And that is how you can get some indication of the wear out of the tube, but nobody is telling you if the tube is really worn out or bad or still good. So that is a bit difficult with curve charts to understand if the tube is still good or bad. But you can say still some things about it. Now, this tester uses a DC voltage for the filament. That means that I am artificially reducing the voltage of the heater. So I have now minus 13 volts here for this measurement point. But to compare this with the data sheet, I would have to subtract the half of the heater voltage of this. So the heater voltage is 10 volt. I have to subtract 5 volt from minus 13, and then I get minus 18. So to compare this with the data sheet, I would have to look, what is this tube doing at 630 volts, 90 milliampere? What is the grid voltage needed? If this tube I have here is totally new and same as NOS, then I would find minus 18 volts in the original tube charge of General Electric. This is how you can see if the tube is at least the same as NOS, but it stays always difficult to judge the wear out condition from a tube chart. The best thing you can do in the end is, if you think the tube is reasonably good with grid voltage, because if not, you can have to forget about the whole tube. If it's reasonably good, you take this measurement point and you find here this GM, and with some of your construction abilities, you can reconstruct the GM from the General Electric datasheet at this measurement point. Then you can say, well, the tube has the same GM or a lower GM. And if it's lower, the tube is worn out or at least used reasonably well. That's how it's done. But as you can see, it stays difficult. And if you want to compare really the tube to the original General Electric data sheets, that is not so easy, because this tube chart stops at 750 volts. It doesn't go any further. And you need like 1500 volts to compare it with the General Electric data sheet. That makes it additionally difficult. But you can, if you know how to construct the GM at any other working point of the tube charge. Well, this is more or less where I have to stop this video. I hope you liked it. Here's a nice close-up of the tube inside this beautiful Sofia tube tester.